All right, so I think we're ready to get started with our next session here. So we have Hunter Howard from ACC Water Solutions, and it is on fog, fat, oil, and grease, I think, management strategies in wastewater treatment. With 8 years experience spanning both the wastewater management solutions sector and as an industrial treatment operator, Hunter's gained hands-on expertise in developing and implementing various treatment processes across many wastewater treatment systems. Joining ACC Wastewater Solutions in 2022 as their Western Canada sales manager, he specializes in biological treatment products for managing incoming water and wastewater at collection systems through to treatment plants and lagoon-based systems. Please welcome Hunter.
Thanks, everyone. As she has specified, my name is Hunter Howard. I'm the Western Canada sales manager for ACC Wastewater Solutions. Our goal as a company, just as a whole, is to aim to help municipalities and their operators be aware of the significant benefits that can come from biological treatment solutions and the help that they provide. All of which, in terms of products and solutions, are backed with documented case studies, in-person and in-field reviews, as well as it's all led with a lead the science mentality. My presentation is going to be kind of on the title as said, fat, oil, and grease management strategies within wastewater treatment, and that's both inside and outside of the treatment facility. As a point of clarity, kind of before we begin, because fat, oil, and grease often leads me to stumbling on the words, I'm just going to refer to everything kind of all either as a fat or I'll refer to it as FOG or FOGs, and just want to make a point before going into the presentation that this is what I'm talking about. So what do I mean exactly when I'm talking about inside of a system or outside of a wastewater lagoon system? And that's simply just referring to inside of a wastewater system, we're talking about the wastewater treatment plant or a lagoon, depending on what kind of system you're currently managing. And then outside of a wastewater treatment system, we're just talking about collection systems. So lift stations, wet wells, again, varying depending on what exactly you're seeing in the system yourself that you're managing. So a quick introduction before we really dive in. There are a few things that I want to first distinguish. First, by nature, fats are a hydrophobic molecule. So for those who don't know, a glycerol backbone attached to 3 fatty acid chains. These fatty acid chains are bound to the carbon molecule that has the carbon bond or the alcohol bonded to it. Second, the fat structures are typically very long in total carbon count and don't provide access to the carbon molecule very easily. Why do we care about this? And the reason being is when you're looking to actually deal and manage fat, oil, and grease, you're looking to begin the digestion process. And in order to do so, you need access to those carbon bonds in order to start to break it down. So you can see on the photo here, the first one is just a generic chemical structure of, again, the glycerol backbone, the 3 fatty acid chains, and then the triglyceride or the fat molecule that we would see. Whereas in the second image, again, it's a 3D rendering of what a long fatty acid chain would look like, just to give you a better idea of how compact the carbon bonds actually are, where the red circles are essentially equivalent to the oxygen bonds, just showcasing that that's where we're trying to get at to when we're digesting fat, oils, and greases. And it's very compact and very dense. So in order to get there, it takes a lot of work, or it takes a certain set of criteria in order to make that happen. And then third, when I'm talking about hydrophobic, for anybody who doesn't know, hydrophobic is just further defined to tending to repel or fail to mix with water. That just means that that's why fats often, for the most part, do float on the surface of your system. This isn't the case 100% of the time, but it is the case the majority of it. And we can get into that a little bit further as the presentation does go on. So how do they make it into our how do fats, oil, and greases make it into our systems in general? Well, first, they're very common in food waste. So if you happen to have a commercial stream or a residential stream, residential is really more depending on the actual size and dietary preferences. So if you have a very small community that have a tendency for high fatty foods, again, that impact is likely going to be more severe than if you're dealing with a township or a municipality of a couple thousand people. Again, it's going to be more on the commercial side. So for example, restaurants, et cetera, that's what you're going to see most of your impact for. When we're talking about industrial processes, those also contribute. Most of the time, the industrial processes are more loading in the oil and grease criteria, in that the systems itself are dealing with lubricants or coolants more on the manufacturing side. Majority of the time, there are release parameters that need to be set before these industries can actually send you the water. So they do need to limit how much is coming down to the system, but it's still important to know that, again, you can get different types of contributions from these industrial systems as well. So in summary, it's a really long-winded way of me saying that there's probably some form of fog coming into your system, whether it's actually creating an impact or whether it's actually creating a serious problem or an issue for you guys. You guys is also dependent and respective on what needs to actually be done. So now that we know where they're coming from and common ways that they could be impacting your system, I just want to kind of run over just a few of the more popular options, some things that you guys are likely seeing or may not even realize is actually impacting your system because of fog management or unmanaged fats that are within. So first off, heavy accumulation is typically one of the more common issues when you're dealing with fat, oil, and greases. This leads to blockages in pumps. It can lead to high or low level alarms in your lift stations becoming jammed or stuck. Secondly, another really common one is odor concerns. Odor is obviously another one of the most common ways that fats are impacting your system, just because you're dealing with high fat content. If that's not being digested over time, that's going to start to smell. Additionally, FOGs can contribute to hydrogen sulfide conversion. So this is some that people may not know, but sulfate reducing bacteria are commonly found in sludge waste, which is also coming into your system in tandem with the high fats. The reaction that takes place between sludge and fats often creates an environment within the water body that removes oxygen. And when fats and sludge are combined in this way in the right ratio, it can actually lead to the incoming system water becoming anoxic in certain scenarios. If you pair that with SRB, which just stands for sulfate reducing bacteria, and a really high sulfate concentration, this isn't talking about hydrogen sulfide that's dissolved, but rather a high sulfate concentration depending on what industries you're managing. This creates an environment where the SRB can really thrive. The bacteria themselves, they take sulfate in an environment where they are favorable with no oxygen. They actually use sulfate as their electron acceptor instead of oxygen. So they'll take the sulfate, they'll reduce it in a reaction to create hydrogen sulfide, and then in equilibrium continue to promote further oxidation of hydrogen sulfide to a sulfuric acid, which we know is obviously very corrosive, but more importantly is actually very toxic, especially even at just low level concentrations. So if you have a lift station that has pitting on some of the metals on the grates, likelihood is, aside from, again, odor concerns that smell like rotten eggs, you likely have a hydrogen sulfide issue, which, if left unmanaged, can become very toxic and potentially deadly. It's nothing to really kind of joke around with. Another area where FOGs are known to be a concentrated issue is when dealing with COD levels. For those who don't know what COD is, just again further defined as chemical oxygen demand, and if left untreated, can encourage the growth of problematic bacteria and furthermore overload the treatment process entirely because of the loading the organics are depositing in your system. So just to elaborate just a little bit further on COD. COD is an indicative measure of the amount of oxygen that could be consumed by a reaction in a measured solution. So this is just a really long way of saying that if you have COD in a system, you're looking to measure the amount of organics per volume of water. The important takeaway with COD and why we want to actually take the time to understand it is that with high COD levels, it often means that you have high organic loading. And as I mentioned, high organic loading often leads to a system's depleting DO levels. And as many of us know, DO levels are very important for the quality of water. If that gets too low, you can run into significant issues later on down the line. So managing the CODs that are coming in through the high fat is very important. So now that we have some of the basics down, just kind of a generalized summary for the rest of the presentation, it's going to take place in two parts, focusing on very similar subtopics for each. So in first, we're going to be talking about FOGs inside your system or in your collection system, sorry. So we're talking about lift stations, manholes, etc. We'll kind of briefly talk why we should care about them, why they accumulate in these areas, and current strategies for mitigation and removal, some which you may be familiar with, others that you don't. And then elaborating a little bit more on biological treatment strategies and the benefits that they bring, the benefits that we've been able to bring to a lot of the clients in the field as well. And the latter half of the presentation is very similar in subtopics, but with a focus more inside the wastewater treatment plants. So depending on if you have a wastewater treatment plant or lagoon, it's going to be a conversation on how they actually impact that area differently. So slide 7, for this one, just kind of brief overview. We want to talk about FOG inside your collection system. So why exactly do we care about them in this area? And kind of as I touched on earlier, lift stations, manholes, and underground piping often have mechanical components to them that obviously are looking to move the water, and they're often also in low flow areas as well. Pipes become blocked and pumps can become plugged very easily. Fats form together readily and really easy with other fats. I'm sure many of you are familiar with large fat bergs that accumulate all across your system. And it's just because, again, with hydrophobic molecules and the actual interaction with fats, they like to bind together relatively quickly. Mix in any type of plant or fibrous materials, flushable wipes. They are just an absolute breeding ground for creating monsters within your system if left unmanaged. Additionally, this is also the first point of interaction that you get with the fats in your system. You get to see how the system is being loaded, and then arguably on the other side, how you can look to manage it before it moves down and creates severe problems into the actual plant and the efficiency of it. So we know FOGs are a pain. I think it's probably easy to say that nobody's going to argue with that. So what are some of the current strategies that, again, are likely really popular that you guys have dealt with in the past? I'm sure what comes to mind for many is that of physical or mechanical means. So we're talking about jet trucks, vac trucks, anything that can essentially pick up the fat, get it out of your system, but let somebody else deal with that. And then just general manual removal. It's never really ideal. However, it's often, again, one of the more common ways of managing systems like this, just because of the benefits that it does bring. So of course, like with most things, there are pros and cons, and I want to go over a little bit of the pros and cons on each strategy. And again, at the end of the day, not looking to sway or say one is better than the other, just evaluate what you guys are currently managing with and what systems and what strategies you could be using, whether you know about them or not, to help give you the best results for what you're looking for. So first thing, when you're dealing with current strategies with physical and mechanical management, I'm sure one of the things that's very common is that it doesn't often require a lot of planning, especially if you're using a jet truck. It's a matter of somebody making sure that, hey, there's a jet truck scheduled for this week or for next week, and you just need to be able to be there to help out whatever needs to get done. As well, manual removal, depending on various factors, is also kind of used and seen as one of the most standard or, again, easiest to complete. If you're an operator, obviously that changes completely when you're talking about management in terms of how easy it is. Operators, obviously, you guys are the ones doing the work, so it's not easier for you, but it's just seen as a standard across the board for higher level management. On the flip side, looking at more cons and more negatives associated techniques for the strategies themselves. It's obviously very labor and very time intensive. If you have a small lift station, at the end of the day, it might not take as long as something that's doing well over 1,000 or 1,500 cubes. However, it's still time intensive, and often because of that falls on the back burner, because as an operator, you're handling 100 other jobs in the day. So dealing with the fat accumulation, as long as that's not currently an emergency or an issue, it's not always going to be the first thing to get done each day. And additionally, systems, as we've been speaking to some of the operators here, often require confined space, which is never ideal, especially when you're dealing in the operator realm. So that's obviously another type of certification and other details that need to make sure that they're being handled before you're going into a position of cleaning out these systems manually. So continuing on, an option that some of you may be aware of or may not be aware of, it's more chemical and heat style of management. Those unfamiliar, chemical solvents are really good at helping temporarily dissolve fats and can be applied to the accumulations themselves. And this point, again, I would like to mention it is the italicized temporary is there for a reason. Furthermore, heat can be applied in tandem or standalone to help change the phase properties of the fats. So we know when fats get cold, they gum up, they become really heavy accumulations. Using heat helps change their phase properties from more solid to more liquid, helps soften them up and actually remove them, which again is only a temporary fix because once heat dissipates, it's going to move back to whatever the temperature of the water is, which is often cold. So some key takeaways with this form of management, the results are quick and it's really hard to argue with that. Solvents are really good at initially dissolving fats, and heats accelerate that even further. However, as I mentioned, it is a temporary solution. Chemicals are consumed by the reaction that they take part in, forming byproducts once finished. If new solution or new solve isn't consistently applied, what ends up happening is as soon as it's used up in its reaction, it's going to become exhausted. And the same thing, as I mentioned, goes with heat. If you're not applying heat consistently to the system, it's going to balance out to whatever the water coming in is, and especially being out west, that's often very cold. So this is why when you end up doing chemical or heat management techniques, it works great within the actual lift station, helps remove everything off the walls inside the system readily and really easily. However, all you're really doing is just pushing the issue downline. It's a temporary solution that you're removing whatever you need to do off the walls right now, but you're just going to send a whole slug load of fat oil and grease to the actual water treatment plant or the lagoon, depending on what type of system you're managing thereafter. So if you're on a utilities team or an underground team, this might be the best thing since sliced bread. If you're on the wastewater treatment plant receiving it, you probably hate them every time they would do a solution like this, because now you're just dealing with it in high quantities. And additionally, when you're dealing with solvents, another thing you have to be careful with is, I mean, us as humans, we can't just readily handle solvents. There's PPE that's obviously required for this type of treatment. Bugs, microbes don't like it as well. So you have to be careful. You could overconcentrate and overpopulate the concentration of these solvents in the system and actually harm, but potentially even kill the bugs that are happening down in the system too. So this leads us to biological management. This is this is at this point talking about biological solutions. Before really diving deep into it, I want to kind of quickly cover a few key tangents that I believe are important before continuing on. In general, there is a lot of misinformation regarding bacterial and enzyme products in the field and how they affect wastewater and collection systems. So the first thing that I really want us to be able to understand is that there is actually a difference between when someone says it's a bacterial product or it's an enzyme product. When you're discussing products, I want to be able to help you as an operator be able to actually clarify exactly what you're talking about. Because again, bacteria and enzyme are often used very interchangeably. So below, you can kind of see a table on the next slide here, where we're looking to actually break down the difference between bacterial or an enzyme product, or rather just bacteria and enzymes in general. The biggest takeaway that I really want for us to have is that bacteria actually produce enzymes, and this isn't vice versa. Enzymes don't produce bacteria. These enzymes are often a means of the bacillus naturally creating an accelerator for itself to help achieve whatever goal it's actually trying to go for. So for example, there are a handful of bacteria that are actually really good at digesting FOGs and breaking down the long fatty chains into a food source for your system, as the enzymes they create help accelerate in that process. And the system itself is, again, really just a long-winded way. I'm just trying to kind of get to the point that it's bacteria and enzymes are very different. So using them interchangeably, especially when you're having conversations about biological management solutions, needs to be identified, because if you're just adding bacteria to a system versus an enzyme, that could completely change the rate at which the application happens, the actual benefits you're going to see to the system, and just a whole host of other important notes. So when we're talking about biological products, we're talking about bacteria cultures that can be added to a system to help supplement or fulfill a specific role more effectively. So say, for example, the population of the actual system, the bacteria that's present, isn't where it needs to be in order to be effective. This is where, when adding a bacterial product, can become beneficial, because you're looking to repopulate, increase the actual culture count of the bacteria as a whole. Where when you're talking about an enzymatic product or an enzyme, you're talking about the concentration of the produced enzymes that help accelerate these bacteria do what they need to do. So at the end of the day, if you're adding an enzymatic product, you're looking to help accelerate the job that the bacteria need to be able to accomplish over a short period of time. Most of the misinformation leading to the crossover of these words really just comes from not fully understanding the biology, and that's, again, from the solution providers, not on you guys. Solution providers can also maybe just not be sharing these details because they don't want you to be asking the proper questions in order to see the treatment or the solutions that needs to be. And also additionally, they want to make sure that at the end of the day, you guys are using a product that's obviously going to make, hopefully going to solve the issue for you, just by throwing something at it and hoping that it sticks. If it solves the issue, great. If it doesn't solve the issue, well, again, they haven't provided you with any of the information to really lead to a target solution. It's, oh, sorry, this should work, it didn't, and then they move on. So when talking about biological solutions, you should always try to have conversations about what the actual root cause of your problem is. So why aren't the bacteria present if you're looking to add a bacterial product? Why is the population dying? Why is it not sustaining at a level that it should be? If it's supposed to be naturally occurring in the system and it isn't, there's an issue. So throwing more bacteria products at it is probably not actually going to solve it, because they're not going to be able to retain themselves in the water body anyways. They're probably going to die off similar to what they were doing naturally. You should look to engage with the solutions and the providers to have them help clarify exactly what the products are and what they're doing. And a lot of the time when you're dealing with questions in the misinformation that comes from biological solutions, it's just a lack of asking questions and also a lack of knowledge being provided, which isn't fair for anyone. So we're following this mentality of understanding how the products work, understanding the biology and the science between why and how effective they are, has led us as a company, is that we're able to tailor treatment solutions based on how we know the science actually works, and learn about your system and having conversations with you and how we can solve the root cause or get to the root cause to actually, again, correct whatever issue could be going wrong. Sometimes the other strategies don't actually provide a solution to the system. If you're dealing with mechanical management, again, you're just looking to remove the sludge and let somebody else deal with it on the other line. If you're dealing with chemical solutions, again, it's solvent, it's temporary. You're just pushing it from an area of issue downline to, again, where it becomes an issue for whoever's managing the water treatment plant or the system after that. Through this and through biological studies and understanding the science on our end, it's allowed us to directly manage accumulation issues while also reducing the impact and often actually increasing the overall efficiency for the rest of the system. Again, if you can recall the loading that fats, oil, and greases cause, if you're managing it and actively digesting it and breaking it down, well, if you're doing that ahead before it's making it into your wastewater treatment system as a whole, you're going to reduce the impact of the actual the deposit in the sludge, the nutrient loading, your COD levels, and then indirectly your DO levels. It's a really fast snowball that, if, again, left unmanaged, these types of things can happen. So with another long-winded explanation of why biological treatment strategies, again, are important, again, similar to the other ones, I just want to touch on the actual strategy, and that is biological management. Boil it down, is the application of target-specific bacteria, enzymes, or biostimulants added to a system to actually actively break down any of the accumulation that's taking place, not just move it down further into your system. We define as a company biocatalyst as enzymatic products. We define when we're talking about bacterial or microbial products, we're talking about just the bacteria themselves, and then biostimulants as key nutrients, additional products that can be added to help bolster the bacteria to make sure that they're going to be in the most effective form possible. So really what we're looking to do is, if products are properly designed, we're able to achieve drastic results in a short period of time, which is one of the benefits of biological. Again, enzymes are really good at what they do. If you collect them, culture them, and apply them in an increased concentration, you're able to reduce the FOGs fairly drastically in just a short period of time, as well as because you're adding bacteria that are biologically active, they're going to help provide benefit to your system where you're applying it, as well as anything further on down line. So issues you may not see in pipings later on are all going to see the same benefit. And instead of just pushing it through, it's going to start to turn it into an actual benefit for your system as a whole. Additionally, when we're talking about strategies, again, even with biological, I obviously think it's great, bias aside. However, it's not perfect. A few things to mention when dealing with biological solutions is, first, if the influent itself isn't changing, so if you're still going to see high incoming FOGs to your system, it's going to require ongoing biological management strategies. So that means that you can't just add it once and then all of a sudden it's going to stay in there forever. What ends up happening is, as you receive your influent, you're going to need to apply products further on to make sure that you're continually managing the issue. Again, if influent changes take place, even though they're unlikely, that's great. There's probably always going to be some type of FOG coming into your system. So this is going to be an ongoing treatment system. However, once the original accumulation has been managed, you can reduce significantly the actual amount of treatment that's required for the system as a whole. So what might happen at first may be a very aggressive treatment, but once you get things under control, again, it's the snowball effect. It's easier to be proactive in management strategies than reactive. And once you get to that point, you can reduce it heavily. And then the second point, again, you're dealing with biologicals. At the end of the day, we know bugs don't like cold weather. Just like, I mean, some people like cold weather, but not everybody. So similarly, you can get efficiency changes that take place depending on how cold the water is, because again, the bugs do slow down in colder temperatures. However, when dealing with proper biological management strategies, these things should all be considered before moving forward with the strategy itself. They should be taken into account before you move ahead. So since I'm talking about the benefits of biological management, I want to showcase some quantifiable benefits that we've seen using our solutions just as a whole, just to, again, kind of back up what I'm saying to give you guys an idea of what we've seen in the field. So figure 1 here contains some data through an independent case study that was done by the University of Wisconsin, where they measured treatment results of Agrisula on a controlled mix of FOGs. It was a composite mix of butter, coconut oil, and lard. As you can see, over the course of an hour, both biological treatments, that's ours as well as an unlisted competitor, achieved increased degradation results of the FOGs compared to the control, which had no additional product added. Our Agrisula is the darkest line, and it hit nearly 60% degradation of that composite mix just within its first hour. Figure 2 shows both products, a control and a control sample again, as well as the treatment applied previously. And as you can see in this sample, what they did is they actually took a water collections from lift station that had high fog loading and ran the same results. Agrisula, again, our product, the dark line, saw nearly 80% degradation over the course of that same 1 hour. The difference, and rather for our product, the increase in the success can be attributed to the makeup of the incoming waste. Butter, again, oil and lard, they're very high in fat content. So that would be assuming one of the worst case scenarios that could actually take place. We saw 60%, whereas in, again, more realistic, higher volume of water, when you're dealing with a lift station, the fat content isn't always as high. So this just is attributed to the actual increase of the product in the system. And then the final slide here, again, same case study, just outlines the overall performance of all 3 samples, just detailed numerically. If anyone is interested in reading this case study cover to cover, I'd be happy to connect with you. I can email it to you. I'd love for anybody who'd be interested to actually take a look and look at the research that was done. So you, again, can understand the quantifiable benefits that biologicals can bring and have been able to bring, both obviously in case studies, but in the field as well. So with all that covered, where does that leave us? We're kind of rounding the first half of the presentation, and we're going to be moving into inside wastewater treatment systems. So bias aside, biological management brings quantifiable benefits compared to other strategies. It's easily incorporated into almost all collection systems, either through manual additions, but again, you're dealing with a biological product half the time. If it's a liquid product half the time, so you could use dosing pumps that just make it a lot more autonomous for you as an operator. Additionally, we can achieve results in a very short period of time too, which again kind of rivals that of chemical or solvent treatment. It works quickly, where ours actually works quickly, but actually solves the issue by beginning to digest down the FOGs. So that way, whatever loading to your system would normally be seen, it's actually just being generated as a food source for the bacteria that normally want to break this stuff down as it is. So we can actually look to solve the root cause of the problem, which is something that many FOG treatment strategies don't actually get the chance to do when dealing with collection systems. So again, as I mentioned, we talked about FOGs inside collection systems. It's why do we really care about, why do we look to actually care about what's happening inside the wastewater treatment plant? And that's, again, really boils down to 2 things. Arguably, if you're looking to manage FOGs ahead of the system, I mean, if you're managing them there, why should I care about them inside your wastewater treatment plant or lagoon? And like I said, the 2 things, it really boils down to often FOG management hasn't always been a priority. So the buildup has actually already taken place and it's moved its way throughout your entire system. As well as for the second point, the issues that actually arise inside a wastewater treatment plant are different from that take place outside or inside the collection systems. So for those who don't know, one of the most common issues within a wastewater treatment plant, it happens oftentimes in lagoons, but you see them much more often, this issue much more often in the plants themselves. It's actually foaming. Foaming is a byproduct often of unmanaged FOGs actually making their way into your system. Specifically, they can contribute to that of a filament growth, an increase in filament growth, and these filaments, when overpopulated, move to the surface of the wastewater system, where increasing in population actually leads them to begin with foaming issues. The two filaments that are most of the time the largest contributors or troublemakers are that of nocardia and microthrix. These are the two filaments that often, again, are the biggest issues when dealing with foaming taking place and overpopulation of filament growth. To give a better understanding of filament growth as well, again, want to kind of take a little bit of time to dive a little bit deeper on the system as a whole and why filament growth actually has its impact and how it's related. We need to look at the biological characteristics of filaments. So nocardia and microthrix have certain advantages over your normal flock-forming heterotrophs that are present on the front end of your system, and they utilize high fog loading to actually get themselves ahead. Their cell walls have increased fat content, which at first wouldn't really think to be a serious issue, but because, again, we know fat is hydrophilic or hydrophobic, it has a light density, which is why it sits on the top side of water. Because of the filaments themselves having the fat content, the higher fat content, this also allows them to sit on the top side of the surface of the water, which is where the FOG is accumulating. So they're directly by their food source in order to grow and rapidly overpopulate. Second point is that they're actually better at naturally producing the exoenzymes to increase their efficiency to degrade fat. So as I mentioned, bacteria create enzymes. Filaments are really good at creating enzymes to help that degradation process take place. The fats themselves are also taken into the cell's wall and incorporated into the cell's membranes. Again, the reason this is important is most time when you're dealing with bacteria, they actively look to metabolize the products that they're eating. With filaments, they can incorporate it into their cell wall, which is much faster. So it allows them to increase their biomass much more quickly, increasing the overall population count. So this is an issue, is when it often happens very quickly. You go from seeing a little bit of foam to next thing you know, you have 2-3 feet sitting on the top side of your surface, and it's because of this. So again, because of those characteristics, if left unmanaged, it can lead to additional treatment and efficiency concerns. If your flock-forming heterotrophs are struggling to increase their own biomass and grow their population, this actually also affects your entire system as a whole. There's only so much space in the water body. So if you happen to have filaments that are overpopulating and overtaking the system entirely, this leaves less room for your actual flock-forming heterotrophs to do the job that they need to do to begin to digest down the remainder of the BOD in the system and actually see, again, beneficial treatment parameters to your system as a whole. So where we may see foaming as maybe just a minor inconvenience, it really just does showcase and put a spotlight more so on the system, and whereas many just see it as, oh, it's something that we have to deal with, it should actually be taken into consideration that if left unmanaged, it can get really, really bad quick. We happen to know some people in the field who have had foaming take place in excessive amounts to where winds have come up and picked up the foaming and dumping it on local roads and riverbeds because it got so out of control. So it's something that it's definitely, if you have foaming, you should consider, again, looking at least a little bit more below the surface and understanding how we can actively manage that before it gets too far out of hand. A second point, kind of as I alluded to a little bit when you're talking about foaming, when you're looking at the system efficiency and the bacteria population count in the system, if foaming is taking place, it means filamentous growth is happening, which means, again, there's likely an efficiency concern or potentially efficiency issues that you're currently dealing with because you're not having the heterotrophs be at the population that they need to be. This is, again, more aligned with wastewater treatment lagoons. Again, foaming might be taking place, but if you have high incoming FOGs, again, you're taking away from that space in the system as a whole. So excess in nutrients and undigested Undigested nutrients over time can deposit in the sludge and the sediment layers. This also in lagoon causes high organic loading. It increases sludge and sedimentatious layers, which takes away from your retention time, which then takes away from the efficiency of your effluent parameters. So everything when you're dealing with biological is a snowball. So at first it doesn't seem like a concern, but there's always a tipping point. And then when that tipping point hits, again, that's when you really start to have to scramble. So again, another long-winded way of kind of introing the issues within the system. So what are some of the current strategies within management styles inside wastewater treatment systems? If you happen to be a part of a wastewater treatment plant, some of the ones I'm sure you're familiar with are dissolved air flotation or DAF. That's the process of running air or an aeration system in order to help float the FOGs and some of that larger biomass to the surface and essentially decant themselves to the water treatment body. Simply skimming it also off the top of the system helps a lot as well. So that's an opportunity or an option that's very popular. Both are very effective with what they do. And again, it's hard to argue that. You do run into some issues, however, especially when you're talking about DAF. It's not readily available for all wastewater treatment plants. It can be expensive. And again, it's not something that you actually ever see in lagoons because of that. Emulsified grease is also something that has been captured by a carrier molecule, so soaps, detergents. DAF and skimming processes don't actually work to remove that because when it's captured, when it's emulsified, it turns it from hydrophobic to hydrophilic, which means it's actually actively mixing you with the water. So there's no way for air or any type of skimming devices to take that off the surface because oftentimes it's not residing in the surface. Moving into chemical management, again, I didn't really intro it onto the summary just because I just want to make a quick knock to it. Chemical defoamers, these are products that don't directly manage FOG levels, but can be oftentimes the most cost-effective way to deal with the byproducts of them. Implementing large mechanical systems can be costly, and sometimes due to the incoming daily flow being very large, biological management in order to apply proper dosages to see the treatment take place can also become costly too, depending on how fast or how much water is moving into the system. So chemical defoamers do have their place. They can be used to help mitigate the foaming nuisance and keep things under control, assuming that there are no additional efficiency concerns. This is something that's common for many, and again, is totally acceptable. If you're just looking to manage the foaming, you don't have efficiency concerns. Again, chemical defoamers are something that you can use and apply to your system to really help out. One caveat that's important to note with chemical defoamers, however, is that many defoamers that are out on the market are silicone-based. Silicone is not good for bacteria whatsoever. So if you are using a chemical defoamer, it's important to know that whatever defoamer you're adding into the system doesn't or isn't silicone based, making sure that you're not hurting your system even further by just trying to manage the foam right ahead. So again, we get to biological management strategies, and similar to collection systems, it's the application of target specific bacteria to a system to help solve your issues. The benefits of the shortcomings of this are very similar. Again, temperature reliant. If the influent isn't changing or being reduced entirely, it's going to be an ongoing treatment strategy. And again, that's something that can be heavily reduced after the original application takes place, but just important to know. Similar as our products before with collection systems, there have been a handful of case studies done by the University of Wisconsin to help us give a comprehensive understanding of exactly what our biological management solutions are doing and how effective they are. The objective of the study for the product in the wastewater treatment plant was to determine the effectiveness of Quicks-IM-L and other biocatalysts that we provide and study the tested removal of fatty acids from the spiked wastewater treatment samples over the course of a 27-hour period. This was used with a handful of FOGs. So just to name a few, a bunch of oils, so canola, peanuts, and vegetable oil, bacon grease, etc. The case study found some pretty incredible results too. Within the full experimental period, Quicks-IM-L reduced the concentration of FOGs in every sample by at least 83%, overall on a running average closer to 94%. It was able to outperform samples by an average about 36% within that same time window. And also some information or some specifically important details that were found as well. The first measurement taken from each of the samples showed that Quicks-IM-L specifically increased the rate at which fatty acid removal took place. So not only overall did it reduce it by significant amounts, within the first 2 hours that was accelerated, which we all know retention time in wastewater is important. So being able to increase the degradations of fat, oil, and grease before they're moving through your system is paired really well with biological treatment solutions. Just due to some time limitations, I'm not going to go into each product tested again. As you can see on the slide, the presentation, on the slide itself, you can see kind of everything listed that was done in the case study, and similar as before. If you do happen to have any questions, you want to read it cover to cover, I'd be happy to share this information with you so you can actually take a look at it yourself. This one is a fairly large treatment sample, so I highly recommend taking a look at it. So kind of before rounding out the presentation as well, when you're dealing with biological studies, I do want specifically that within a wastewater treatment plant, I do want to kind of mention one more thing. That's microanalysis and filament testing. This testing brings a definitive understanding of the biological makeup of the water. It gives you an idea of if filaments are present, an idea of sludge age, oxygen penetration, and provides a full report back to you and the team on any of the discoveries that are found, either showcasing how the system is being well managed or exactly how the system is occurring any type of issue. This is, again, another benefit of biological management. We actually get the chance to look under the microscope, understand what your system is doing, how it's performing, whether it's performing well, whether it's performing not so great, and be able to take a target application in order to help solve those issues. The next few slides really just indicate what an actual report looks like. If foaming is an issue within wastewater treatment plants, or you're just looking to understand the actual mixed liquor and understand how the biology is taking place, there are different testing and different results for that. The one that's up on the board here is just that of a mixed liquor. So they took a sample and they wanted to understand how the system was performing overall. So as you can see, there's bacteria growth, filamentation that's present. You also get an idea of sludge age. If you're doing especially an activated sludge plant, this is very important information to have because you need your sludge to be healthy and to be active in order to see the treatment efficiency take place. And then again, everything's all printed out in terms of what filaments are found, the abundance they're found in, and then we can also give recommended cases or causes for why they're present. And then in terms of biological treatment practices, et cetera, we can move on to making sure that whatever you guys need or see is being biologically specific and targeted across the whole board. So I do have a few slides, just some product showcases. I'm not going to go over them just because we are a little short on time. If anybody has any questions, again, a lot of the products that I do have here are outlined in some of the case studies that we had done. I would love to be able to connect. We can go a little bit in deeper as well. I can share with you my information and we can kind of talk offline. But as I kind of mentioned, we know FOGs are damaging to the entire wastewater system. We know that there are a handful of treatment strategies that are currently being implemented, each with their pros and cons. And being honest, what may be extremely effective for one operator might not be effective entirely at all for the next. I just want you all to leave having understanding of what's out there, what biological treatment solutions can do, and help clear up any misinformation that's present, and make sure that at the end of the day, you guys are approaching each situation and each solution in a targeted manner to make sure that you see the best results that are possible. Again, I want to thank you guys all for sitting here for 45 minutes listening to me ramble and stutter over my words. I really appreciate everybody again sitting here. And if you do have any questions, I would love to kind of open it up to the floor. And again, if you have anything offline, we're on the trade show, we can connect with afterwards. So thank you.
Thank you, Hunter. Round of applause. Do we have any questions in the room? Sorry.
I've got a clarifier skimming. I got a big sump full of grease. I add your product. What am I ending up? Because we know we don't remove it. We convert it to something else. What am I ending up with?
Yeah, so when you're dealing with biological solutions, especially if you have a clarifier that's moving it, is it, just sorry to clarify, is it moving it like out of stream, out of line of your system to a sump? Yeah, so what you're doing is when you're looking to actually actively break down the fat content, what you're going to do is you're going to take those triglycerides, as we started with at the beginning, you're going to break them down into shorter acid chains, ideally acetic acid. What that's going to do, that acetic acid is readily able to be broken up and digested by the bacteria. So you're going to end up creating a a pile of essentially biomass that's created by the bacteria as waste, but it's actually going to go and actively break down the FOGs. So for a system like yours, again, working in a collection that's offline, what it allows it to do is takes that FOG, takes all of the loading that it could be causing in that system as a whole, and break it down further into biomass. And ideally, what you would actually look to do in your case is apply the FOG products ahead in your collection system and get to a point where hopefully you wouldn't actually need the skimming processes, because what's happening is everything coming in is going to be produced as some type of food source for the remainder of your system as a whole. So in terms of kind of answering your question, you're going to create biomass created by the bacteria, but it's in a system that's a little bit separate. Again, it's kind of a catch, not a catch-22, but it's either you're dealing with high fat content, which then you have to either slug away or have somebody come pick up and deal with, which depending on what the system looks like, not a lot of companies always want to deal with just purely fat content, or you're going to have a system that has bacteria, enzymes in it. It's going to break down that fat, that loading that the system is seeing. It's going to be more biomass driven, less than just high fat content.
I was looking at your product called Grease Jet for use on a jet truck. Just
Yep.
wondering, how is that actually applied to the collection system?
What we do is before the jet truck actually takes or begins its process, you just look to actually add it to the jet truck as a whole. So the product can be added to the actual tank of the jet truck. Give it a little bit of time to mix, and it just increases the overall efficiency of the jet truck. Because again, at the end of the day, we know sometimes jet trucking is what's best for people in the field. This just helps increase the efficiency of it, similar to Greasilla. It's a biocatalyst. It's an enzymatic product. It's going to help soften up that accumulation. So the hot water, as well as the softening of it up, it's going to help increase the overall efficiency, as well as begin that degradation process to whoever is going to haul it away.
Thank you, Natasha. What was my question again? Okay. I've talked to some operators in the field that kind of anecdotally feel there's a real difference between vegetable-based fats and animal-based fats in the wastewater treatment plant and how well the plant will process them. I noticed you had quite a myriad of fats that you tested with.
Yep.
Are there any kind of overarching conclusions you can draw? Like, is an animal fat easier to digest than a vegetable fat and vice versa?
Yeah, let's see. We can go back. Just in terms of product showcase, I was talking about QuickSime, and in that case study that was done, these two enzymatic products again are dependent on, you apply them depending on what the waste is. So for QuickSime, again, it's more for the L stands for lipids. So enzymatic digestion of lipids within the system. So you're dealing with, again, some of your more simple fat, oil, and grease, where QuickSime P is more of a digestion for complete and more complex proteins. So you're talking waste in milk and cheese. So we do have a benefit because, and again, as I mentioned, enzymes are good at helping accelerate the process for whatever the bacteria is looking to achieve. Different bacteria produce different enzymes. So QuickSime L as a whole was able to, again, provide some type of degradation, again, in pretty high concentration or pretty high ratio rates to a bunch of oils. As you can see, just even in the data, again, bacon grease, milk fat, and what's the other one? Yeah, vegetable oil, again, and sesame oil, some of the more complex oils themselves didn't have a full 100% treatment. So in other words, yes, like different oils, different systems do have a harder time breaking down overall, depending on what the actual makeup of the fat or the oil or the grease is.
Any more questions? All right, and just a reminder, Hunter does have a booth here at the trade show. If you guys have any more questions, you can find him later.
Thanks,
on.
everyone.
Yep. Thanks again.
Can we just get everybody to come up front here again so we can?